All right, so here we are for part 2 of the OAA pillow problem. We have already figured out how many cubic inches of stuffing Carson needs to make the cylindrical pillow for his mother. But wait, there's more. Carson decides that he wants to make the pillow bigger. So the problem directs us to compare the amount of stuffing needed when he doubles the length to the amount of stuffing needed when he doubles the diameter, show work, or provide an explanation to support your comparison. Well, the first thing we have to do is figure out the amount of stuffing needed when we double the length. The next thing that we need to do is figure out the amount of stuffing needed when he doubles the diameter. And then we have to compare those two pieces of information. So that's the fourth task. So 4 points, 4 tasks. So here we have just the part of the problem that we're on the second half of the problem. So if I double the length of this pillow, the length turns into, make it double the length. Not sure if it'll let me free the aspect ratio or not. Well, okay, so I guess it won't. But I do need to double the length. So if I double the length, originally it was 15, now it is 30 units. So this is 30 because 15 times 2 is 30. My diameter is still 6 units. So my radius is still 3 units. So this is my second pillow. So again, I'm going to substitute in the values that I know. Volume is equal to pi times 3 raised to the second power times, instead of 15, my length has doubled, so I'm going to multiply it by 30. Now I follow order of operations. So 3 squared is 9, 9 times 30. Volume is equal to pi times 9 times 30. Now we're going to simplify. I'm going to multiply 9 and 30 together to get 270, and then I'm going to multiply 270 times pi. So let's clear this. 270 times 3.14159. I get 848.23. Whoops. 848.23 inches cubed. Now, I would have to analyze my own work and say that I should label what I'm talking about. So this would be pillow with doubled length, just so it's easy for my grader to see what I'm doing. The easier your work is to read, the better it's going to be. So that is the pillow with the doubled length. So here's all of that information. Notice that drawing a picture is a great strategy to help you organize your information. Now, the second part of this task is to double the diameter. So if my diameter doubles, my new diameter is 12. My length is still the original length, which was 15. So common mistake right there is to assume that I'm still using the doubled length. I am not. So volume is equal to pi times, now my radius is going to be 6 because my new diameter is 12 times 15, not times 30. Don't make that mistake. Follow order of operations. Pi times 36 times 15. So I'm going to do 36 times 15. I get 540. Volume is equal to pi times 540. And I'm choosing to do it this way so I don't have to round to the very last step. So I'm going to multiply 3.14159 times 540, and I get 1,696.46. 696.46 inches cubed. All right, so if I double the diameter, this is diameter, this is how much stuffing I need. So notice that when I double the length, it gets significantly bigger from the first pillow, which was 424. If I double the length, it gets to be almost twice as big. If I double the diameter, it's almost 4 times as big as the original. Now, another common mistake is to not read carefully what you are to compare. So the problem says compare the amount of stuffing needed when he doubles the length, so this, to the amount of stuffing needed when he doubles the diameter. So we're supposed to compare these two things. Now, I can tell just by looking that this one is almost twice as big, but I'm going to check that. So I'm going to pull up my calculator, and I want to know, is 696.46 divided by 848.23 almost 2? And in fact, it's exactly 2. So if the volume has doubled, I need to ask myself, what does that tell me about the amount of stuffing I need? So I might write something like, the volume doubles when I double the diameter compared to when I double the length. That tells me that I need twice as much stuffing. I need to pull this up a little bit. That tells me I need twice as much stuffing when I double the diameter as opposed to doubling the length. And hopefully you'll be able to see that in just a second. Well, apparently not. Okay, as doubling the length. So the volume doubles when I double the diameter compared to when I double the length. That tells me that I need twice as much stuffing when I double the diameter as opposed to doubling the length. Now, upon rereading, I realize that I'm not the person making the pillow. That tells me that Carson needs twice as much stuffing when he doubles the diameter as opposed to doubling the length. So that is how we complete this problem. Now, before you finish the problem, you should really go back and double check to make sure that you answered all 4 parts. So I'm going to go back to my original slide that showed all parts of the problems and make sure that I answered all of them completely. So Carson wanted to make a cylindrical pillow for his mother's birthday. The pillow was to be 15 inches long with a diameter of 6 inches. It's filled with stuffing. In your answer document, determine how many cubic inches of stuffing Carson will need to make the pillow. Show your work. So I'm going to look back over that. Here is the original pillow. Carson will need 424.11 cubic inches of stuffing to make the pillow for his mother. I used a volume formula. If I just glance at it, I don't think I made any mistakes. So good. I answered that part. I finished that task. Before he just started making the pillow, Carson decided he wanted to make it bigger. All right, so that tells me that my stuffing should probably be larger. And if I just glance at these answer, yeah, I can tell that my stuffing, I need more stuffing when I double the length or double the diameter. So I made it bigger. Good, checked that. Compare the amount of stuffing needed when he doubles the length to the amount of stuffing needed when he doubles the diameter. Show work or provide an explanation to support your comparison. So I chose to show my work. So I did the work for doubling the length, and I got 848.23 inches cubed. If I double the diameter, I get this, 1,696.46 inches cubed. So I see that I showed my work for both of these parts, and then I needed to compare. So I'm going to read this sentence. The volume doubles when I double the diameter compared to when I double the length. That tells me that Carson needs twice as much stuffing when he doubles the diameter as opposed to doubling the length. So I showed my work and I compared. Just to double check, I did have, this is a 4-point question. I had 4 tasks. This was my first task, second task, third task was to double the diameter, and the 4th task was to compare. So if you did all that, you would have gotten a 4 out of 4. So I would like to see this the next time you have a problem like that. Thank you.